Welcome back again, Science Wars, for another flipped video here in our 6th grade Atlas Science class. Today we're going to be talking about the first part of force and motion, which is potential and kinetic energy. Our EQ for today is going to be what energy is associated with forces and motion. So that's going to be our big main focus. Now for some instructions. Be sure to create Cornell notes on the page that is listed on Google Classroom. You should be reading the instructions that are posted there before you start the video anyway to make sure that you know exactly where and what you need to do. At the top of your Cornell notes, please write the EQ. What energy is associated with forces and motion? And then after we complete the notes today, you're going to complete a Google Forms quiz that is attached with this video on the Google Classroom post. So let's go ahead and get started then. What is energy? Energy is the ability for something or a system to do work. In other words, to do work means to cause some type of change. And to do change, it takes energy. So if we increase and decrease the energy, we can affect what are called physical variables. These are things that can be measured in a system. For example, temperature, speed, position, pressure, motion. Anything that can be measured in a system when we cause change is a physical variable. Well then, what really is a system then? Let's talk about that real fast. A system is a group of elements that form a complex whole. So all of these little parts come together to make a much larger whole system. So one system could be your stove. So if someone turns on the stove burner and it's underneath a pot of water, energy from that burner will cause the pot to heat up. We learned that in heat transfer. The heat will then cause the water to come to a boil. Well, this is a small system. This shows that the relationship between energy and the system of the water-filled pot. We introduce energy through the stovetop. That energy causes change, it does work, and it causes the water to boil. So this is an example again of a small system, but systems can be as large as you want. It could be looking at the whole universe, a solar system, a whole planet. Anything that a scientist needs to look at specifically to study is considered a system. So now that we understand what energy and systems are, how is energy classified in a system? Well, there are two major forms. Okay, we're already aware of these: potential or PE energy, kinetic energy, or we call it KE. Remember that potential is stored energy. That is pretty major. You might want to make sure that you write that down. As well as kinetic energy is the energy of motion. I would definitely write those two things down so that you don't get them crisscrossed. Now, the total amount of potential energy and kinetic energy that's in a system has a name. It's called the mechanical energy of a system. This is the energy involved with motion, because potential can turn into kinetic and kinetic can turn back into potential. So it is a mechanical aspect of it. Hence the name mechanical energy. So let's look at an example of that. Look at this person on the swing. We have points X, Y, and Z. And as the swing moves, mechanical energy here in this system, the potential plus the kinetic at any point, never changes. Okay, so let's kind of look at what happens as what's going on in this diagram. So the person swings back to start at position X. And when he does, the swing is going to pause for a very small moment. At X, this swing has only potential energy. It's at the highest point that it's going to be at. So it has nothing but potential here for that one moment that it stops moving. As he begins to fall forward, he's going to gradually gain speed. And as it falls, that potential energy is going to slowly be turned into kinetic energy. It's transforming. Now, as he gets here to position Y, the bottom of the swing, okay, at this point, there is nothing but kinetic energy. He's at the lowest point he can be on the path of the swing. Therefore, this is where his kinetic energy will be the maximum. This is also where he'll be swinging the fastest, where his speed is the highest. And as he continues forward to point Z, okay, he's going to start to slow down. His kinetic energy is beginning to transform back into potential energy because his height above the ground is raising. Okay, he's getting higher off. And then when he gets here to point Z, he's back to nothing but potential energy. Since Z and X are at the same height, okay, it's not higher or lower than the original point, then he has converted all of his kinetic energy back to potential once the swing stops in the forward motion. Okay, of course, he's going to begin swinging back the other way. And just like going forward, going backwards is the same. Potential energy is going to convert to kinetic energy all down the path of the swing until he recrosses point Y, where he's back at 100% kinetic energy. And then we're going to lower the kinetic, but increase potential all the way back until he starts back over at X. So energy is constantly transforming at this point. So a major thing we definitely need to understand is that, therefore, because of all of this and how potential and kinetic energy work here, when potential energy decreases, kinetic energy increases in a system. Also, the opposite occurs. That's what it means by vice versa. As kinetic energy decreases, potential energy will increase. So, these two energies are highly, highly related. Okay, what is the differences and similarities between these? Well, similarities, both potential energy and kinetic energy are measured in joules. Joules is the amount of energy needed to do a certain amount of work, okay, or cause a certain amount of change. More joules of energy means more change can occur in the system. Okay, so think of it kind of like a currency. The more joules you have, the more you can change about the system. Now for the differences. Potential energy, of course, is stored energy. Okay, stored energy can be found in chemicals, like what makes up food, batteries, and fuel. These are all potential energy examples. And potential energy can also be based on gravity. Okay, its position. So the higher up something is, the more potential energy it has. Okay, if I hold a pen and a pencil, okay, because this one is higher, has more potential energy, and this one's lower and has less, when I drop them both, the one that is going to have more speed, more kinetic energy when it hits the desk, is going to be the one that started with more potential energy because it had more energy to convert into kinetic. Okay, so earlier we talked about how the mechanical energy of the system. There is more mechanical energy for this object than there is for this object based on position alone in this example. And then one other major difference between these is that kinetic energy is the energy of motion. Anytime anything is moving, okay, if you toss something and it's flying through the air, okay, we have kinetic energy. And potential is, of course, it's just staying there until it does something. Okay, so that's going to wrap up this first video. So now that your notes should be complete, I need you to go back to the Google Classroom post, and you are going to complete the Google Forms quiz that is posted there underneath this video. You only get one shot at the quiz, so be sure that you have chosen your correct answer before submitting the form, so check your work. Also, kind of a reminder, or I want you to remember, you just created notes over this topic, so please use your notes, okay, that you have just created on this quiz. If necessary, you may rewatch portions of this video as well to help guarantee that you are understanding the concept when you take take that quiz. Alright, well, Science Warriors, that's going to be it for this video. Hopefully the next one will be short, but it is going to cover some pretty intense information. But I'll see you next time. I'll see you in class, and you guys be good. Peace.